could be addressed during this workshop and whole program. And so the first speaker I'm glad to introduce is Andrew Haslett from UK, and so he's Director of Strategy and Chief Engineer of the Energy Technologies Institute, which has a broad view on all kind of issues relevant there. He's also a fellow of the Institution of Chemical Engineers and of the Royal Academy of Engineering. And so his experience spans a large-scale technology infrastructure to end-user adoption in a turbulent organizational environment. And I will not go through all the details of your bio and leave you the floor for your presentation.
Well, thank you. Thank you very much, Louis, and thank you very much indeed for whoever it was who decided to invite me. What a fantastic workshop this is. I'm really pleased to be here and somewhat humbled by being invited to speak. So, as Louis says, until 2 weeks ago, I was the Chief Engineer, and before that, the Strategy Director of the UK Energy Technologies Institute. And over a 12-year or so period, because the Institute is now being run down to closure, we spent over £400 million on developing and demonstrating energy technologies all the way across the chain from supply to end use, likely to be important in future UK low-carbon energy systems. And the bulk of the money was spent on steel and metal and designing steel and metal. But actually, if I look at the projects by number, the number of different things we did, and the amount of intellectual effort expended, the bulk of that went on gathering data, building models to analyze and optimize designs for future energy systems, and particularly in doing consumer research, which is a particular kind of data. Consumer research data isn't really quite like taking engineering measurements, you know. Consumer reactions to something are understandable, quantifiable, but they're not the same as measuring wind speed. I'm going to be drawing on all of that experience in talking to you, but in particular I'm thinking about some work we've done in our smart systems and heat program, and some work we've done on consumer uptake and charging for mass market consumers, so not the kind of people who are currently driving electric vehicles or hybrid vehicles, but people who we hope will be driving them in the future, real consumers as opposed to early adopters. Unfortunately, the ETI has not yet published the detailed results of those pieces of work. That should be happening in the next few months. So if you'll forgive me, I'm not going to preempt the ETI's publication by sharing some of the details that I might otherwise have shared. I've got some details I can share with you, but my talk is very much based on being deeply engaged in those details. Oops. So we spent a lot of time thinking about future UK energy systems that were affordable, because if you can't afford it, there's no point talking about it, secure, or perhaps in common language, reliable, robust, sustainable, of which I guess in the present generation the most important dimension of sustainability is carbon emissions, greenhouse gas emissions, but there are others. So water usage is pretty important, and there are other environmental problems in energy systems. Big cities, NOx and particulates from cars, for example. And equitable, which I guess a lot of people would describe as fair. So those are, in very broad strategic terms, the things that you're designing whole energy systems and analysing whole energy systems for. My talk is not going to be about mathematics, but about the problems that we're trying to solve with mathematics. So in a way, I was delighted with the first talk, which I found personally very helpful in categorising the structure of the kinds of solutions that you might come up with problems. I'm going to turn the telescope the other way around and talk about the kind of problems you're trying to solve. And I particularly liked the definition that Warren gave of system states, which are only those things that you need to know in order to make useful decisions to deliver your objectives or objective function. So hidden states are those things which you need to know in order to make those decisions which you cannot easily know. And in general, in most classes of problems, many of the most important states are hidden. And that's what I want to talk about, those hidden states. If you look at energy transitions, and I have a lot of experience and I know a lot of people who do it in the UK, in general, there are pathways towards decarbonisation that involve pretty much the universal use of electricity. They are not the only viable pathways, and in fact most sensible pathways also involve hydrogen and various other things which I'm not going to go into. And in the UK at the moment there is a major discussion going on and a lot of work in which I'm still involved, looking at hydrogen into heating. In fact, I was writing a paper about it last night, and I intend to have some correspondence with some of the other people about it. But for the sake of today's discussion, I'm going to assume that a sensible pathway starts off by decarbonising electricity, which addresses the electricity that's already used in domestic buildings for lighting and appliances, and also industry and commercial and institutional buildings. But my focus is on domestic buildings for reasons that I'm going to explain. You then move, and we are about to move, hopefully, into electrifying transport by cars, and possibly vans as well, but I'm going to focus on cars because most domestic drivers drive cars and not vans. And then, some time away, you deal with the enormous challenge of decarbonising space and water heating and industrial and commercial heating, but I'm going to talk about domestic heating. The size of those circles represents, on the left hand, the median energy usage in homes in the UK for lighting and appliances. The cars bubble is the average energy consumption if all of UK miles were driven in electric cars. And the one on the right is a very aggressive and optimistic assumption of how little energy you would need to put into space and water heating in houses if you have very efficient heat pumps and heating systems that are well controlled, and you spend a very large sum of money on making quite large parts of the existing building stock more efficient. And when I say very large, we're talking a few £100 billion. So we're not talking about deep efficiency gains, which would take £1.5 trillion, more than about a year's GDP, but we're still talking about some very large sums of money and some substantial efficiency improvements. One of the fundamental points I want to make is that the load classes of electric cars and heating are very different from the load class of lighting and appliances. One of the difficulties you have in discussing that is that people make assumptions that they're going to be sort of the same, but they're not. Therefore, you may need very different technical infrastructures and different market infrastructures to deal with them. You might even have different prices for charging vehicles and for providing lighting and appliances in the same house at the same time. And I would argue you should, but that's a different discussion. So, within lighting and appliances, you have a lot of energy going into things which are small. The internet router, the burglar alarm, the lights. They can be on all the time or for quite considerable periods of time, but each of them individually is small, and therefore even within an individual household, and particularly across groups of households, you get diversity of statistical behaviour so that the load is reasonably predictable. Then you have loads which are large, like kettles or electric showers or microwaves, and these are quite considerable loads, well beyond the aggregate capacity of the supply side across a group of houses, but they don't last for very long, and they're not correlated, and therefore you don't have the problem of having peakiness, except, as the system operator will tell you, kettles at certain points in television programs, although with diversity of television programming, fortunately now that is less significant problem than it used to be, although I understand that National Grid were ready for and achieved a very expected surge in tea making shortly after the kiss when Prince William married Kate. So they saw it coming and they were ready for the cups of tea that were going to be made in order to celebrate the event. That is an unusual thing. Cars have to charge for hours at 7.5 kilowatts each. It tends to be cold at the same time across large parts of Great Britain, and the closer the other houses are to you, the more likely they are to be cold at the same time as you are. That places a load, at least on the local distribution system. those are not, whereas the electricity requirement for cars is sort of fairly constant and can be deferred actually. You don't have to charge the car now, whereas you do have to cook now, or you do have to light the house when it's dark. With heating, you heat when it's cold. And that's very, very peaky. So these balloons are actually extremely misleading because they talk about energy consumption. What drives the cost in power systems in the future will be peak load. So the question is how you manage that. The top blue line there is the peak load is the load curve, half hour by half hour, for Wednesday the 18th of January 2017, a typical winter day. I guess there might have been peakier days, but they're not that much peakier because appliance and lighting isn't that much driven by weather. The orange curve is the UK national load, so this isn't just domestic, it's industrial, commercial and domestic, but it is end user load on a similar day in July, a Wednesday. And then the grey is my estimation of the proportion of that winter peak curve that was driven by domestic appliance and lighting. If you look closely at that, you'll see that the peaks in the total demand are largely driven by consumers. There is some variability driven by industry and commerce, and more by commerce than by industry, but the peakiness is driven by consumer behaviour. You leave the office with the lights on, you drive past the shops that are hoping you'll stop, you get home, you switch the lights on, you have a bath, you have something to eat, you sit in front of the television, you do your email, whatever it is. At the moment, we pretend that electricity is a commodity with a commodity price, and we look at the commodity pricing for electricity. I know there are lots of people in the room who don't agree with this, but this is in general what people do. Certainly economists who are not that familiar with energy assume that the right way of buying electricity is price per kilowatt hour, levelized cost as it's called. But as we move away from fuel being a component, it becomes very hard to find anything which is variable. Almost all of your costs are either fixed operational costs or capital costs. And those are there driven by your peak. The most severe circumstances is what you design your system for. Worse than that, as you decarbonise, the peaking plant remains high carbon and less efficient, and so your peaks are particularly moments in time when you have high carbon emissions if you don't manage them. As we have seen from some of the earlier slides on PV or wind availability, the price of electricity becomes very variable because you have more or less renewables available, even if you have other more flexible or more base load low carbon generation like nuclear or gas turbines with CCS. And those supply variations are diurnal and seasonal. We saw sunlight is only available when the sun is up. Can't do more than 50% decarbonisation because it's dark half the time and there's less sun in the winter. And wind, of course, is more available in the winter and the summer, which is a good thing in the UK because we've got lots of wind and we have higher energy demands when it's dark and cold. So there's some quite important considerations. Why do we care at all about the consumer end? We care about the consumer end because actually, although we think about people consuming energy, people don't consume energy, they do things. And there's a huge amount of natural storage at the consumer end, which is gigantically more than anyone has ever described batteries being used for. You know, the cost of buying batteries to provide this scale of storage and this power of capacity is just unthinkable, at least for the next 20 or 30 years. So if all cars in the UK were electric, with about a 300-mile range, which is a bit less than the range of the car on the left, that has a 400-mile range, so it'd be a little bit tight. You'd have 1.3 terawatt hours of electricity on average in batteries, and 1.3 terawatt hours of headroom, because the batteries wouldn't all be full all the time, and people tend to drive on average with their battery half full, between nearly full and nearly empty. Interestingly, that's what people do with electric vehicles once they use them as well. If, and it will never happen, but if they were all charging at the same time, that would be 220 gigawatts. You will see from the ratio between 1.3 terawatt hours and 220 gigawatts that that's serious storage. If you look at most frequency and short-term operating margin battery installations, they're the other way round. They have half an hour's storage, an hour's storage at most, whereas here we have hours of storage. In the UK, we're rapidly removing domestic hot water tanks and providing fossil fuel boilers which have a large enough capacity that you only have to wait an uncomfortable amount of time for your bath to fill. So in houses that would otherwise have a 7 kilowatt gas boiler, we have a 30 kilowatt gas boiler because you need 30 kilowatts if the bath is going to take less than 15 minutes to fill. In houses that still have a hot water tank, which is less than half of them, my view is that at the moment there are about 0.6 terawatt hours of heat storage, and although the power capacity of the boiler is much higher than that, nearly all of them have an immersion heater of 3 kilowatts each in order to provide emergency backup for those very rare occasions. So in principle you have 3 kilowatts of dispatchable electricity demand that would immediately displace fossil fuels sitting in houses, but there is no market or technical infrastructure to make use of it. Although a lot of people with PV on their roof, when they discover they can't really use most of their PV, find ways of getting into the hot water tank and are a bit frustrated because of the amount of intervention. So again, a significant amount of storage at a somewhat lower power rating. Data on the thermal mass of building fabric inside the insulation, so the thermal mass that tracks the temperature in the house, is quite limited. We do know there's a very wide range of time constants, so we have houses with low thermal mass and low leakiness, where the thing heats up and cools down very quickly, or usually overheats and then is very difficult to cool down without opening the windows. We have houses with high thermal mass with a very high leakage rate that still have a low time constant, so not that much value for storage. And we have houses which are reasonably well insulated and still have a high thermal mass. There's a non-trivial thermal mass also in the heating systems, the metal of the radiators. So if I heat the house up for an hour or more after I've done that, the heating system is hotter than the room, which is a control problem in terms of overshoot, but is an opportunity perhaps in terms of phasing heating. If that was supplied by heat pumps, that would run at about 130 gigawatts of output on the heat pump, so the input would be less than that and would depend on how cold it was. The input would be higher the colder it was, not dissimilar to the hot water tanks. If you put those two things together, of course, if you want to manage space and water heating together, you might consider an engineered solution where you have a more compact, higher intensity heat store. Such things do exist. They're expensive. Of course, if we had the market and technical infrastructure to make use of them, they would be scaled up and would become cheaper. Chicken and egg problem. So we want to make use of this variability of demand, both the storable demand and when people might choose to do things. Somebody once said to me, you can achieve a lot with pricing, and I said, but I doubt you can get people to heat their houses, to light their houses when it's light and not when it's dark, and to heat it in the summer rather than the winter. So there is a natural underlying demand pattern, and then you have the storage, which allows you to schedule the energy supply, the electricity supply, a few hours away from the moment of peak service provision. And these are the two questions. They're not complicated questions. When and where should this vehicle be recharged? And that is a personal question. It matters to the individual when and where their vehicle is charged, and the answer for all vehicles is an aggregate answer over all of their personal questions. There may be some flexibility in the individual answers, and you can use that flexibility in how you manage the aggregate. Vehicles move around, and people can charge them away from home, although the cost of providing charging away from home is higher than the cost of providing charging at home in general. And you can't move heat supply around. Although some people go out to the pub if it's cold because the pub is heated anyway, and you can get the benefit of it. Most people prefer heating their home because that's where they live. I guess 90% of people or so. So when should I put the heat in the house for the hot water and the space heating? And the best answer to those questions is very contingent on those factors. So the pattern of the daily life of the occupants and or drivers, and of course a driver is someone who has left one building and is going to another one typically, unless they're going for a day out in the country, and even then they return to a building. So the touches on buildings are quite important for drivers as well. The overall local and national demand, so clearly I would prefer to do it off-peak than at peak. Constraints on the transmission and distribution networks on the supply side, either all the way back to generation, which tends to be transmission, or more locally the coincidence of different people on my substation wanting to do things. And then forecasts of the supply, the capacity of the resources, which in a renewables world is significantly driven by weather, and of course demand in terms of heating is also driven by weather. Quite a complex problem. People don't consume energy. In fact, if you go and interview most people, they haven't a clue what you're talking about. Energy is a distressed purchase. They do things and then they get a bill. They have absolutely no idea where the bill comes from or why. They can't control it or manage it. They don't understand the technologies that provide it. And they just wish that the energy industry was more like the mobile phone industry, when they got what they wanted and they knew what they were going to pay. And all the rest of it is just some kind of technical nonsense and incapacity as far as they're concerned. That's what they do, the things on the outside. And what I want to talk about, and I probably missed some, but those are the ones that come to my mind. Those are the things they do, and that causes a demand for energy or the need for supply of energy. I'm going to talk about psychological hidden states. I'm going to focus on need or expectation. So I have two people I'd like you to think about. One of them is going out to the theatre, gets home, wants their car to be recharged, has something to eat and has a shower. And the other one isn't going to the theatre, in fact they're going to stay at home. For whatever reason, they get home, they're planning to eat later, they're going to watch the television, their car can be recharged tomorrow morning, they want a bath just before they go to bed. So one of them has needs which are much closer to the peak, and the other one doesn't care, actually. And those are hidden states. How do I know that that's what those two people want to do this evening? And I'm going to talk about that. And then, as well as, and there are other psychological hidden states as well, which can be quite material to how people view the goodness or badness of the answer. And I'm going to touch on that as well, but I think that's a bit more complicated and not for such a short talk. And then you have physical states which interact. So what is the charge in the battery? Probably knowable. What is the amount of hot water left in the heating tank? In most UK houses, not currently knowable, but you might be able to infer it. And that has an impact on people's psychological state, the environment in which they find themselves. So their psychological state is contingent. And if people don't like the environment, they do things to change it, otherwise known as changing the set point on their heating system. So I come home with a cold, I feel like a bit more heating, and I turn the heating up. Didn't do it last week, didn't do it the week before, didn't do it the week before that. Why not? I didn't have a cold. The cold is part of my hidden psychological state. Okay. Comfort, the perception of thermal comfort depends on those four factors there on the right. So it's a common experience that you feel warmer on days when the sun is shining, even if it's quite cold. In fact, if you're doing some kind of physical activity, you take off all the layers of clothing you put off because it was below freezing because you're feeling too hot, partly because of the exercise and partly because the sun is shining on you. Drafts are important, so you feel colder on a windy day, even when it's sunny, than you do on a still day. The same is true inside houses, and we all know that humid heat and damp cold are a different experience than dry heat and dry cold. Unfortunately, for some reason, we only look at air temperature as being the factor in comfort inside houses, and I can assure you, if you wander around with your hand pointing at things and feeling the radiation of cold windows and hot radiators and so on, you will discover that radiation is also important in homes. We don't talk about it because it's a bit awkward because we can't measure it, and radiation is incredibly difficult to measure. I know some people do actually measure it inside test houses because they actually realise how important it is and therefore they want to measure it. There is no way we're going to instrument houses to measure radiation temperature. I think, although who knows what those clever sensor engineers might do. Humidity we can measure very easily, but because we have all these engineers obsessed with measuring air temperature, we don't bother to measure it, even though it's incredibly important to the fabric of the building and the experience of comfort. The chart on the left-hand side is designed to illustrate the problem of hidden states. It's also designed to illustrate the problem of diversity. So there is not a standard human being around whom we can design or design solutions, whoever he or she is. People are very different. People are very different. And that seems to be a very hard concept to get across, that you're trying to satisfy this person under these circumstances. People seem to think there are universal solutions. There aren't. This is a very nice piece of work done by the Thermophysical Research Group at Maastricht, who've done a number of nice pieces of work. And what it's plotting is the thermoneutral temperature range of a group of similar Dutch women in their late 20s and early to mid 30s under laboratory conditions, dressed the same activity pattern, selected so that their body shapes and so on were similar. This is a highly controlled group of people in a highly controlled environment. The thermoneutral range is actually quite a technical concept, so I'm not going to explain it, but essentially it's the range within which people, under those circumstances, are not likely to try and change the environment. If you like, they are sufficiently comfortable, they're not going to do anything about it. And the open dot is the point at which they have the optimum or best level of comfort, what you would expect over time they would learn to set the temperature controller at if the temperature controller did actually deliver thermal comfort. The vertical axis is the length of the bar and the horizontal axis is temperature. And you can see an enormous diversity of thermal range. And if you have a group of people whose thermal ranges don't overlap but are small, you've got a problem. And I think you can start to see that although many of those pairs of women would not have had a problem sharing the same space with a thermostat, that there are some who start to be a bit problematic, particularly people with short ranges where the dot is at one end or the other. In a trial we did of 30 houses a couple of winters ago, we found with a lot of measurement and a lot of consumer research, we found 2 houses where the occupants clearly did not have overlapping thermal ranges under uncontrolled conditions, where they were wearing different things, different activity patterns and so on. In one of them, when one of the occupants went away on business for extended periods, the whole temperature settings of the house changed while they were away. And in the other one, the temperature distribution of the living room, and there's a clue in how important people think temperatures in living rooms in the name of the room, so it's a sort of nodal room for looking at these things, was bimodal, depending on who expected to be in it and what they expected to be doing in it. And talking to people, although this wasn't contentious between them, they were aware of the fact that managing the thermal environment was something that required cooperation and understanding between them. Okay, so, and of course, perfect example, the physical environment is hard to know completely, and it affects people's comfort. The individuals perceive that quite differently, even in the same physical environment, or can do. I've had lots of conversations with people about demand management, which is often presented as denial of service. If I could stop people using a service at a time when I haven't prepared to supply it economically, then the world would be a better place, and this is good for them because it'll save them money. So if I force people to sleep on the streets instead of having hotels, it's a good policy act because it saves them the cost of a hotel. Excellent. So let's have a look at showers, because showers are quite a big load, and therefore I could possibly engineer, controlling them from a control room on the south coast of England. So people spend between 2 and 20 minutes in a shower, which is interesting because it can't possibly take 20 minutes to get clean in a shower, and therefore there must be some hedonic element to that. People are in the shower because they want to be there, because they enjoy being there. And I know from other studies I've done in other jobs on cleanliness, that cleanliness is actually quite a complex psychological concept. It amounts to people believing they're clean. It's got nothing to do with whether they are clean or not. Obviously, if they're not clean, they can tell if it's gross, but beyond that, it's the expectation or sensation of being clean, and also the sensation of enjoyment of having a shower. Typically, electric showers in the UK are 9 kilowatts, which I think you might describe as the tepid dribble level of service. So most people find that it's not really quite as much of a shower as they want. Some people are more accepting of it than others. And if you have 60 kilowatts of heat input from a hot water tank, rain shower, which is what that one is, most people think that's pretty reasonable. Unfortunately, if you keep giving people the 60 kilowatts, they start believing that the 9 kilowatts isn't enough. So electric resistive heating is a bit problematic. It's quite easy to detect the operation of a shower if you measure the electricity supply to the house, if you look at the water flow into the house, and various other things, you can probably tell that the shower is on. And that shower there, the control module there on the right, is actually a battery-operated piece of electronics which is Bluetooth connected to the main control unit. So it won't be surprising, I think, in future if your shower is actually connected to your home automation system and there's an app for that. What would happen if someone could switch off the shower, either the heat, so the water turns cold, or just the water and the heat, so that the energy is not required, while you're in it. You know, the man on the south coast goes, "No, I don't think you deserve a shower." No, I don't think so. I see from your body language that most people agree with me. Okay, so suppose we have a world where I can agree, I strike a contract with my supplier whereby they can prevent the shower being started. So I go to take the shower, and I press the button and nothing happens, and a little panel comes up that says your contract does not permit you to have a shower at this moment, please wait. And clearly the sort of psychological reaction to that is there an override? I've got to go out, I want to be clean. When can I have the shower? How much would it cost? Oh, it'll cost you £10 because you're breaking your contract. Why are you punishing me for wanting a shower? So there's a whole load of sort of psychological and operational considerations that go beyond what you might describe as the simple economic, commercial, or the simple engineering technical model. And it can get more complicated still. So I'm fairly sure there were some people, probably people who are very poor and very worried about energy consumption, or very frugal people actually, who would accept the idea that it's a socially responsible and economically sensible thing to do to strike that kind of contract, and they will organise their lives around it. Let's imagine we do the same with the microwave. So here is my meal. Excellent. I press the button, nothing happens. Fine, I can wait. I'm a visitor in someone's house, my daughter's house, you know. I don't realise she struck this contract. I put the curry in, I press the button, it cooks. I put the rice in and press the button, it doesn't cook. Okay, I've got a hot curry and some rice. What am I going to do now? Well, if I knew I had the contract, maybe I would do what that one is. That's actually a 2-pack with the rice and curry in the same thing, so that when I press the button it doesn't work. But again, you know, there's that hidden state. What was I trying to do when I pressed the button? What were my expectations? How am I going to react to the situation? You may think those are rather simple-minded examples, and that's true. They're deliberately simple-minded examples to sort of make the point, because it's gross. There are much subtler examples than that. Okay, so here is some data which the ETI has published from our managed charging trial. So first of all, we have the control group. There's about 200 drivers driving battery electric Volkswagen Golfs who are perfectly ordinary drivers. In fact, interestingly, the way they drove them was nothing like the way early adopters drive the cars. They did a lot more miles. And the blue bars here are the control group. So the only app they had told them what their state of battery charge was. Their vehicle started charging as soon as they plugged it in and finished when it was full or when they unplugged it. So they had to manage the charging by plugging in and out. They had no incentive to plug in or out at any particular time. In fact, they had no control over when the vehicle charged. That's a little unusual, actually. Most vehicles these days have an app that allows you to decide when they start charging and when they stop charging, but unless you're on an economy tariff, you also have no incentive. In the UK, certainly the economics are going on. The economy tariff to charge your car are highly dubious. It's not at all obvious any rational person would do it, because they would lack confidence in the return, because the market is stacked against you. And the behaviour of those people, and they also had a polar card, so they were able to charge away from home for free, and the trials were done in areas with a significant public charging infrastructure. Even so, they only did a third of their charging away from home on average. It was only at home that we managed the charging. We were not able to interfere with the public charging points and manage that, or to do translocational charging. This was an early piece of research. Nobody's done anything like this before, so we just wanted to see what the reaction to the concept of managed charging was. Fortunately, it wasn't to charge away from home. And of course the economics are interesting, because the benefits of managing the charging were less than the benefits of just charging away from home would have been. So that tells you that people like charging at home. They're willing to pay for it. The orange group had effectively a time of day tariff, although it was reward points. And their app said they could control when it started charging and when it stopped charging. So they plugged in, and then they could program the app to set when it charged. Very surprisingly, they all started charging as soon as the low tariff started. Who would have guessed? Not entirely. You can see there's some early charging behaviour here of people who felt they needed to charge for whatever reason before the low tariff, or simply didn't care. Why should I care? I'll just plug in and charge. I don't care about the reward. The message is slightly confused by the fact that within each of the managed charging groups there was a summer and a winter charging, so the peak would be even more pronounced if you only looked at just summer or just winter. And then finally we have the user-managed charging group, these pale people here. And they had an app which said how much charge they wanted by when. So not atypically, they wanted their car to be fully charged tomorrow morning when they wanted to set out from home. The charging algorithm we used wasn't very clever, because we were really just trying to measure the effect, the consumer response, rather than do something clever with balancing the energy charging. And whereas the orange people knew what the tariff was, they knew how many report points they would get by time of day, the pale blue people didn't. They just knew there would be a reward. And we did some electricity price modelling for 2013 based on a particular view about the market and the generating mix. And the points were allocated equally according to two rules. So one rule was they got points for being available to charge when it was likely that electricity prices would be low. And then they also got points retrospectively for being available to charge when they were actually low. And the psychological element to that was to create an expectation that certain behaviours would be rewarded, but to make sure that over time the actual reward depended on reality. I think that might have been a bit clever because they just responded by not asking for it to be charged unless they needed it to be charged. You can see there's some interesting differences in short-term charging behaviour here, I think caused by that uncertainty in expectations as to what the reward would be. Again, in the user-managed charging group, when they had this very clear tariff structure, once they'd settled down, by and large, 2/3 of the time, they stuck with the schedule, start charging, as soon as the low tariff, and 1/3 of the time, they pressed the Charge Now button. So presumably they had some reason why they wanted it to be charged now, which overrode the benefits of the reward. The supplier-managed charging people, interestingly, were less inclined to press the Charge Now button. Maybe they had some confidence the supplier would look after them. And they spent far more time particularizing the request to this event. So, nearly 1/3 of the time they had a specific request for this event, which is interesting, isn't it? So, there are times when I stick with whatever my default is, but there are also times when I have some other requirement and I'm willing to share it. Okay. So if we think about this in terms of the problem I'm trying to solve, using all of the different bags of generic toolkits that we saw earlier, what can I know about the system and what do I do with it? So I can have measurement. Almost certainly I can know at various points in the system the state of charge of the individual battery. I'm not sure what I'm going to do centrally, knowing to 1 second resolution or whenever they're plugged in the state of charge of millions of batteries all over the UK, but in principle I can measure it. The reason that's not a white box, it has a penalty function, it's a bit red, is that adding measurements or adding communications to measurements can be expensive. So although it's very cheap to instrument a new house, it's incredibly expensive to go and measure the radiator temperatures in the existing house. It's not the cost of the wires or the sensors, it's the cost of routing out all the walls and redecorating and all that kind of thing. So measurement has an uncertain cost function associated with it. It's a good thing to do, but it may not be practical. The state may remain hidden. I can seek user input. I gave you some examples there of users providing input about their charging needs. User input has a very low penalty function as long as you do it carefully. As long as you align the question to what people want, nobody thinks there's anything wrong with putting their destination into a sat-nav. If it's difficult, if it appears to be focused on the supplier's needs and not the user's needs, the penalty function for the user goes up dramatically. But asking people what they want in a way that's natural to them, and when they press the button they get it, is great. People don't see that as a cost. However, there's a risk. Let's suppose I get home planning to be person B, the person who is not going to go out until the next morning, and I press the button that says fully charged by 7 o'clock tomorrow morning, please. And the charging algorithm goes, fantastic, I'm going to schedule you for 1 o'clock to 6 o'clock in the morning. Problem sorted. Now then, I'm cooking a very special meal for a very special person, and it's important to get it right, and I'm missing an ingredient. My child has some kind of medical problem. I need to get out now, it's very important to me. And that bloody system didn't put any charge in the battery so far. So there's a risk element that people do not know their needs, and the penalty function can be extreme if they get it wrong. So there might be an option value in doing a bit of precautionary charging, particularly if there is some history, some wider data that tells you what that option value might be. So what kind of other information can I have? Well, I can have general historic patterns of this house, this person, the things they have done, which give me quite a lot of priors that I can put into any model I've got, plausible assumptions. A thing I've been particularly interested in is if you look at people, you often get patterns of behavior which are very typical over short periods of time. So, for example, if I get home and I'm planning to get up early tomorrow morning, fly away somewhere, have a bath when I get up, my bedtime behavior is likely to be significantly different than on days when I'm not planning to do that. Sometimes in subtle ways and sometimes in very simple ways. I go to bed earlier. And if you can detect that in different ways, those recent historic patterns can be quite predictive of short-term future patterns. The problem, as somebody said earlier, Warren, with neural nets is they need enormous amounts of data. A lot of the things that are problematic for people don't happen very often. Therefore, you learn to do the wrong thing in situations of high option value. If you take wider data about other people, particularly if you can show that the patterns of general behavior look more like my general patterns of behavior, you can look for those examples of those rare events from those much larger data sets which suggest that, sometimes people go out in the evening when they said they weren't going to. So I can make inferences. I've got a lot of data there from different sources, combined in different ways to make inferences about my actions. What is my objective function? It's a very clear objective function. I'm trying to avoid dissatisfaction. So some people will be dissatisfied if I charge them a lot of money. Some people will be dissatisfied if I don't give them the service. Some people will be dissatisfied if I start an argument with the other person that they share a house with. The dissatisfaction is a very human thing. It's not too difficult if you get that legendary beer and think about what might go wrong in the situation. It's jolly hard to describe and quantify what you mean by that dissatisfaction. What is the measure I'm applying to these potential future courses of action, these scheduling plans that I'm developing, that tells me whether people are or aren't likely to be dissatisfied? So it's a very simple, very clear, just make sure you don't dissatisfy people. I'll leave the mathematics to you. Sometimes when you look at courses of action, you think, it'd be really helpful to ask. And sometimes that can be psychologically helpful as well, in the sense that if you ask someone and they make a choice, they're more likely to accept the consequences of that choice than if you made it for them. However, we're all familiar with systems that keep asking us things and telling us things in order for us to express the choice we really don't want to know. I keep pressing unsubscribe on a particular supplier that I once bought something from, and they still send me those bloody text messages and emails more than once a day. Nobody wants a naggy heating system that doesn't know how to control your house. So that is a darker red than the measurement because it has a distinct cost function. You're admitting to the user you don't know what to do, and you're asking them to apply their thought, and sometimes the choices are difficult ones with consequences they're uncomfortable about, so you try not to ask people. Okay, that's the general problem of state estimation and decision making viewed from the perspective of, as it were, someone who has to engineer the system. There is a class of thinking about how to extract information from utility data called non-intrusive load monitoring. How many people in the room have been involved in non-intrusive load monitoring? Okay, some of you know about it. That's about the level I expected, some but not many. And essentially it flows from an idea, a 25 years old idea by heart, that if you look at the detailed fine-grained electricity measurements of current or power flowing into a house, you can tell a lot about the appliances that are being used. By and large, a lot of the things that people are doing with that are trying to allocate energy usage back to appliances and things. The whole point of this in my context is to try and look at those short-term patterns of behavior. What can I tell about what people are doing and what will that tell them? So here is a power trace from my house over a 24-hour period, starting late one afternoon and finishing late the other afternoon. And at the most blindingly obvious, I think you can tell when my wife and I left. You can tell what the background load of the internet router and the heating control system and the carbon monoxide alarm is. Down me you can see the fridges. By the way, people's interaction with fridges disturbs that pattern, so you can tell some interesting things about meal preparation. You can also tell, at least you can if you know me and you've looked at this other, that I obviously was out in the garden, because I wasn't making beverages, because you can't see any classic kettle spikes there. And my kettle spike behaviour is very predictable. In fact, if you look at the frequency and so on, it tells you what I'm doing in the house. Back to this point about data fusion and neural nets. I find it very frustrating. I work with people on trying to analyse this kind of data, and I find the data scientists won't look at the human context and the underlying structure of the problem. They just want to throw neural nets or something at it. And the people who are interested in the engineering and human aspects of the problem won't use mathematical techniques to find interesting patterns. They sit and stare at all of the data going, we're looking for something like this. Sorry, you've looked at 0.1% of the data. You need to automate this somehow. So I think there's a huge possibility in looking at fusing what people do with the controls, what you see from other things, from the utility measurements and other data. Almost greenfield space. How am I doing for time, Louis?
5 more minutes.
5 more minutes. I shall finish a little early then. This is sort of an afterthought. It's less to do with the mathematical problem and more with the sort of social context. So there is a lot of debate about the use of this kind of data going on in the world. There are arguments about what the government should and shouldn't know about you. There are arguments about what Google and Amazon should and shouldn't know about you, and what you can do with scraping Facebook data, social context. I see this as on a spectrum from medical data, which is highly protected in most countries and very sensitive, and most people care quite a lot about, all the way through to book purchase choices, which is not that sensitive, but people are still concerned about, and some people think it matters and other people simply don't care. And energy, I think, is a lot closer to medical than it is to book choices. So if we have the energy levels, and I mean emotional and political energy levels going into data protection and privacy that we see already around things which are probably less intrusive and less sensitive than energy, what does that tell us about what we can infer about people's patterns of behaviour and its predictability, and what we therefore need to do to think about energy data and processing energy data? I'd like to talk about agency, autonomy and privacy. There are different ways of describing this. I happen to have chosen a particular one. So if someone comes up and says, Andrew, you're wrong, you should have said this, I say, yes, you're right, that is an alternative way of looking at it, and it's no better or worse than my way. So I'm just introducing my ideas with a particular structure. I'm not saying this is how you should think about it, and I would make the point these are closely related. So agency is a technical term in consumer psychology. It's about the experience or the belief that you're in control of your environment. And people are in control of their environment in two ways. So there is cognitive control, I understand, and there is experiential or operational control, it does what I want. And different people approach this differently. So a famous problem in designing the air conditioning systems in cars was the introduction of climate control really annoyed half of the population. Generally the half of the population that weren't engineers. So I'm very happy with climate control. I set the temperature, and to the extent that the thing knows what it's doing and gets it right, which it doesn't, which pisses me off as an engineer, they're not measuring the solar gain properly, that's great. My wife is an experiencer. She wants to be able to control the flow rate and temperature of the air coming into the cabin. She presses the button and she feels the change. She knows she's in control. She can feel it. It took the Japanese car companies who first introduced climate control some time to come up with the idea of dual controls and also with adjusting the controls so this perfect thing that engineers love called climate control could be overridden by people who wanted something different. Autonomy is about freedom of action, risk adjusted. So if I have to ask someone's permission, or if I don't know what might go wrong, if I choose to do something, if people won't make that clear to me, my autonomy, my freedom of action is restricted. And privacy is a legal term, so it has a distinct legal meaning, particularly within the European Union with general data protection regulations, which within European cultural norms, I think is actually quite a nice piece of law, and has been in the UK, has been implemented very well, and I think in the Netherlands and Germany. I'm less familiar with other countries also. It's also an expectation of agency over your personal information. So, which you might describe as, if I give my personal information to someone, I should understand what they're going to do with it. I should have autonomy in the sense that I understand the risks involved in that and how they're going to be managed, and I freely and knowledgeably consent. I have informed consent. It's very visible. A number of big American companies have come into severe trouble in Europe and complained afterwards that they'd made adjustments as they thought which were adequate. There's a culture clash between different countries about cultural contexts and norms, and it is what it is. These things, anything to do with how I feel about things is about me and my society. Somebody else can feel differently about them. There is no scale that says my views are more important or better than theirs. Okay, thank you very much. Yes, gentleman at the back there.
If I could change the words just a little bit to help with my talk. So when you say these hidden states, I think what you've done is a fabulous job of bringing out the complexity of these systems, that when you interact with humans, there's a lot we don't know. That's a very rich part of it. Instead of using the word state, let me just talk about hidden parameters. Okay?
Yes.
And parameters can be like, how do people respond to a price? It could be that trade-off could be a parameter that I don't know. Sometimes the parameters are static, but I don't know them, and sometimes the parameters evolve over time. But the parameters I don't know, but they can also evolve over time. And sometimes there's parameters where I can influence them. I have some control over them. But they're unobservable. I could call the state of my system my belief about these parameters. So if we use the word state to say what I can measure, which might be a probability distribution. So I understand you use the word hidden state, but if I simply call it unknown parameter, just to change, just so I can use the
So
word state.
I would agree with you that price sensitivity is a parameter and not a state.
Well, you can call it a state. I don't want.
Well, I wouldn't call it a state because it doesn't meet your definition. And by state, I did mean things that met your definition.
Well, so I have found that there's a literature, the pay.The literature, where they have systems where there's something unobservable, that if I can control it, even though it's unobservable, people call it a state.
Perfect.
And they call it a pay.The, which is fine. But if we reserve the word state for what I can measure, which let's call it a probability, so I can observe a probability distribution, a mean and a variance.
So now you have the interesting problem, because you defined states as those things which you need to know in order to take effective action that meets your objectives. And I'm commenting that in my belief, some of those states are not measurable and therefore hidden. So you now have an empty set of states.
But I can observe the distribution of belief about those parameters. Okay, so in other words, you call it hidden, but I still have a belief.
Whose belief?
Let me put it this way: if there's something unknown, I'm going to have a belief. There's different ways to construct that belief, but I'm going to have a belief.
Yeah, so if you're constructing a belief about somebody's hidden state, I would call that an inference or an estimation of the state.
Absolutely.
And that is exactly what I'm talking about, is how you estimate and manage the fact that these states you know are important, whether someone wants to go out or not, or might want to go out, may be hidden from them. Although you wouldn't define that as
what's
hidden,
not
because
hidden
it's the current
is the
state.
distribution. So I do have a belief. In other words, I can work in terms of what I do know, which may be a probability distribution, right?
I think you're changing the definition to suit its tractability, personally, because I think it remains hidden, actually.
Well, no. The actual parameter
Let's talk later. I'd be really interested to have this conversation. Any other questions? Yes.
You go back to this slide on these inferences.
Yes.
Yes, and because for me, when you try to do these inferences, then you try to define some policies and controls that will change the measurement.
Yes.
So the measurement will be impacted by some policies, and then the measurement will change, and then...
Well, so the measurement doesn't change in its history, although your estimate of the hidden state...
The other people will change depending on the price or whatever. So if you infer something to derive some policy...
Could I just say that in my world we don't talk much about price, because consumers are dreadfully price insensitive.
So what are you inferring something for? You are inferring something for what?
So I'm trying to manage cost of supplying the services under a contract where I probably is a bit like my phone.
So you want
I
to
know how much the consumer is going to
Then
pay. What I don't know is how much
Then
it's
you
going to
want
cost
to
to
optimize the
deliver.
contract, but to change the contract.
No,
No.
I want to change the supply. I want to reduce my costs in meeting my contract as their supplier.
And the behavior will be the same.
Sorry?
And the behavior of the people will not change when you.
Well, you
The
know,
behavior is invariant.
I have absolutely no idea what the mobile phone company is doing to make sure I get a good call. I really don't care. The fact that I choose to make calls when and where I choose to make them, and I get irritated if the call quality isn't very good, is what it is.
So there is no feedback between the inference and the measurement.
Oh, no. Well, sorry, there's no feedback historically in the sense that the historic measurement doesn't change, but you're absolutely right that my action can change the state of the system,
Yes.
and the user's reaction to what I choose to do, suppose I send them a message saying, shower now,
Yeah.
that can change the measurement also.
Yeah.
So if you're saying that the actions change all of those things,
Yes.
you know, we get new information about the system, its short-term and its general history comes in, and I have new measurements, new user inputs, and I might even have asked the user for, or they might send me a message, what are you doing? I agree with that, absolutely. It's a dynamic system, a very dynamic system.
Okay, so you have to perform some counterfactual inferences to get rid of the existing policy to be able to do something, because there is an existing policy, an existing contract, and of course the behavior is depending on that.
Sorry, by legal contract, do you mean a set of expectations or?
I think there is a contract, so the people are there is a kind of
Well,
they
no.
have to pay something. They have
So
to
when you
pay.
go into a restaurant,
Yeah.
how carefully do you study the contract the restaurant offers you before you order a meal?
I have a menu. I select something in the menu or
Yes.
So,
Ever sued a restaurant because you felt that the items on the menu weren't quite as described? Or did you have a state of expectation and belief about the experience of dining in the restaurant from previous visits, from what people told you about it and reviews, which had nothing to do with the technicalities of any contract, but were to do with some expectations?
yes.
That is the relationship that people want to have with energy services, not a contract which you can operate on as a lawyer.
Okay.
You really?
There are so many people that forget that there is some feedback and.
Oh, no.
and
In fact,
I see
one of
many people that forget about the fact
no,
that
I
what you do has an impact on what you are measuring. And
Yes.
then there is this kind of effect that is not obvious to deal with. And
look at that dramatic impact.
yes, of course.
Yes?
Yes.
So depending on how I present things to people and what I do with the inputs they give me, it has a transformational impact on the system.
Yes.
That I agree with. That's the whole point.
Yes.
These are really important things.
So it's an equilibrium. At the end, it's an equilibrium thing, a kind of game, or I don't know.
It's a dynamic equilibrium. The system evolves over time, and at times you have states which are observably, you return to a similar state every day. Then things happen that perturb the equilibrium, and it takes a while before you get into a transient equilibrium again. But yes, absolutely. The trouble is we don't know what that equilibrium is going to be because it's a very complicated system. Okay.
There's time for another question.
Oh, time for another question. Oh, sorry. And here I was trying to escape.
You're talking about behavior change, so the penalties and all. Can it be like even giving the incentives? So that
yes,
can be
so-
again like related with behavior change.
So one of the experiences I've had is trying to design the user interface to use in a real consumer trial for both heating and charging management. And it's easy, you sit there, you think about it, you understand it, you have a general understanding of consumers, you've got this view of your mind as to what to do, and you go into a room with other people and you find they had the same view, just not the same as yours, but the same confidence in their view, and in fact your views are incompatible, and you start talking, and after 2 hours of discussion you realise that you don't understand the question. That none of you can come up with a compelling analysis. So actually what we had there were reward points, which did have a monetary value, but the monetary value was obscured from the consumer. We knew what it was going to be, but we didn't make a big thing about the monetary value. We found that consumers really liked the idea of reward points. They found them strangely rewarding. And so, yes, there is something you get in return for success. There is a disequilibrium in people's reaction to winning and losing. People resent losing far more than they love winning. So penalties are a really bad idea in terms of motivating consumers. If you give a penalty to a consumer for non-performance of their part of the contract, that has an enormous financial impact on your relationship with them, and everyone knows that acquiring consumers to replace the ones you've lost is very expensive in your business. So you try and avoid penalising consumers, you try and help by rewarding them. Yes, Louis?
Maybe I can ask another question. So, let's say you are a supplier and you have a set of customers
Yes.
that you want to satisfy in the best way according to their preferences and so on. So you
Yes.
have to learn something about their preferences, how they
Yes.
influence and so on. And there are other suppliers, and all this depends on the amount of data that you
Yes.
can collect over the consumers. Of course, supplier in France maybe has very different kinds of consumers, don't drink tea and so don't have certain preferences. But what about sharing the data, and how much data is really available? If you think about research.
No, that's an incredibly good question. So there is currently about to launch something called the Energy Data Task Force, headed by Laura Sandys, looking, I think, at that question. I was planning to write to her to suggest what she might think about, because I'm not sure that the obvious stakeholders are going to suggest the same things as I would. Not that what they suggest would be wrong. And that is an absolutely central question. So there is enormous commercial value in data. The amount that Uber know about journeys in San Francisco is just enormously more, and in London actually, than the local authority in San Francisco or London knows about journeys that people take. Although in London they know a lot about journeys that people take by the underground and by trains, or the Oyster card. That captures a lot of data. So there's a question then about, which is back to, there's a broader social question about data and autonomy and privacy, which is what data should be shared with everyone, either for policy reasons or even just business reasons. If I share more data, then more businesses can add value to that data. How do I manage that in a way which respects the individual's components of that data? What do I do about the fact that most social policy organisations are hugely underprepared to process large amounts of data, and the people who have the skills and expertise to do that are the individual businesses like Uber? So that is a really important question, which is very active at the moment, or is about to become very active. And it must be incredibly frustrating as a researcher that you can't get access to data that industrial companies tell you they've got and how valuable it is.
Okay.
And I do think that researchers should have access to that kind of data, which is a responsibility that the state should have. There was another question this time.
Yeah, I was going to say earlier about the restaurant analogy that, okay, you don't sue the restaurant, but you may return a meal or you may change restaurant in the future. So there is always...
I can't quite hear the question, sorry.
It's not exactly a question, it was a comment, a follow-up comment on the
Yes.
restaurant analogy that, okay,
Yes.
I will not sue the restaurant if I don't like the food, but I may return the dish once or twice, or I may not go back to the restaurant, or even I may write a very bad feedback
Yes.
on the internet. So there is always some kind of feedback loop, even in this kind of...
Oh, yes, no, I agree. My comment wasn't about that. It was about the fact that it isn't really a contract, it's an expectation. It doesn't have that formality.
Okay, it doesn't really actually make it even more complicated.
It is. And if you imagine the thing that is in the modern world most people want is to have a good review on the internet. So I was delighted by the experience of this energy supplier. And you sort of, what delighted you? Well, that's very complicated. And if you go and look at the reviews, you always have that balance between it turned up on time, it was exactly as described, I thought it was a great price, the instructions were helpful, and appalling supplier! And I spoke to their department and they had no idea they'd lost my order. And you always think, well, some people are never happy and everyone makes mistakes. So you have that balance of outcomes. But the bit you hate is if 10% of the customers had a really, really bad experience, even if it was only 10%. That's why my objective function is to avoid dissatisfaction. You just can't live as a restaurant with too many customers who would never go there again and told their friends. Okay?
I think it's time to switch to the next presentation, so thank you very much. Our next speaker is Patrice Frances.